You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more conversations and articles, please visit thenewstack.io. Now on with the show.
Amazon Web Services is the world's most comprehensive and broadly adopted cloud platform, offering over 175 fully featured services from data centers globally. Millions of customers trust AWS to power their infrastructure, become more agile, and lower costs.
Hello, and welcome to the latest edition of the New Stack Makers podcast. Today, we'll be talking with Jay Pipes, a principal engineer at Amazon Web Services. Originally, we were supposed to record this at KubeCon, but our flight schedules it didn't work with our flight schedules, so we're doing it now. But anyway, we were eager to hear about how the world's largest cloud service uses Kubernetes, and just as importantly, how they are contributed in Kubernetes and contributing to cloud-native open source technologies in general. Jay, welcome to the show.
Thanks for having me, Joe. Appreciate it.
Excellent. I forgot about Jay works on cloud-native technologies in the AWS Kubernetes team, focusing on open source contributions in the Kubernetes ecosystem. He also leads the AWS Controllers for Kubernetes ACK project, and he helps to shape the upstream open source contribution strategies of AWS engineers. So let's dig in there. First of all, I'm very curious, how big is the AWS Kubernetes open source team?
Well, we don't actually have a separate open source team.
Okay.
So at AWS, we take an opinion that if a service like EKS is built on top of open source technology.
Now that's the EKS is the
Elastic Kubernetes Service.
Yeah, thank you. Okay.
Yeah. So we here at AWS take this this opinion that if a service is built on top of open source technology, right, like EKS is built, on top of Kubernetes, and therefore is dependent on the success of that open source project, that it's a responsibility of all of the engineers in the service team to be aware of what's going on in the upstream community, to be contributing to that upstream community and making it succeed, right? Because we just say, well, look, if the upstream open source projects upon which we depend are suffering or not doing well, then our service is not going to do well, right? And by the same token, if we can help that upstream project or projects be successful, then our service is going to be more successful. So we don't necessarily have a separate open source team that only works in open source and doesn't work on internal code or anything like that. Rather, we just encourage all of our engineers, regardless of the sub-team that they're on, to contribute in any way that they can to those upstream projects.
Excellent. Are there particular aspects of Kubernetes that AWS kind of specializes in, or are there problems that you guys have had to solve? Yeah,
for sure.
Tell us.
Yeah. I mean, EKS, I'm pretty sure has the largest number of Kubernetes clusters under management in the world, or at least I think so. And having that many Kubernetes clusters under management means that our service team is exposed to where Kubernetes and etcd, the underlying data store that Kubernetes uses, where the scaling limitations and the production operational readiness limitations of those of that software, where the breaking points are, right? And so many of the contributions that our team members do for upstream Kubernetes and etcd and containerd and these other technologies is around making sure that those constraints, those scaling constraints and production readiness constraints that we run into, that we provide insights to the upstream community. Hey, this is where things break down, right? This X number of nodes, or X amount of traffic to a particular Kubernetes API server, or a good example of a contribution that came out of our performance and scalability sub-team within EKS recently. We have an engineer, Sham Jidagunta, who, in looking at the logs and metric collection from thousands of production EKS clusters, determined that the gzip compression that is enabled inside the Kubernetes API server, ostensibly to reduce the network bandwidth used and decrease the latency that clients experience when talking to an API server, that it actually was increasing the latency for large list requests that clients were making to the Kubernetes API server. And so did a whole deep dive into trying to figure out, well, was it a particular compression level that gzip was hard-coded at 4? Like, could we reduce that compression level? Could we disable gzip compression entirely? What impact that would have on latency and network bandwidth? Those are the kinds of contributions to upstream etcd and core Kubernetes that you'll see coming out of AWS service teams, because those are the kinds of things that our customers report and say, oh, we're experiencing this slowdown in the Kubernetes API server when we have, 1,000 nodes and 200,000 objects of a certain kind. We're seeing increased latencies. We don't really know what's going on. Our engineers go and diagnose what's going on and put together a bunch of troubleshooting information and collate that into white papers and proposals to upstream Kubernetes on how to fix those things. So that's the kind of contribution that we like to spearhead, right? It's direct feedback that we get from our customers that we sort of translate or convert into feature proposals, bug fixes in upstream to address those specific problems that we run into.
So what do you know the end of the story with the gzip latency issue? What was
yeah. So Sham is very detail oriented. I love him. He put together an upstream proposal that had some short-term fixes, some sort of medium-term fixes, and some long-term things. They've already merged some of the short-term fixes, which is sort of like some flags to disable compression and allow the client to disable compression. There's some medium-term fixes that have been merged. I can't quite remember what they are, but some long-term ones are like the API server actually sort of tracking which particular kinds of API requests to enable or disable gzip compression for, which makes the most sense, and sort of doing that, sort of learning over time, to be the most efficient for a particular kind of watch or list request. And different types of objects have, different types of objects that are represented in etcd under the hood, they have different compression ratios, right? And so, for instance, a pod or a secret or a config map have very different compression ratios, and turning on gzip compression makes a big difference or no difference at all for some of those objects. And so sort of a long-term solution in this space would be the API server sort of understanding which objects, which kinds of resources that it is serving responses for make sense to enable compression for.
Nice.
Anyway,
Excellent.
that's just one example of the type of of contribution to Kubernetes and etcd that we like to focus on. I will say though, Joe, our number one priority for all of our open source is any integration between the open source project and AWS services. I mean, it's always been that way. It's just sort of table stakes for us. So things like the AWS load balancer controller or the IAM authenticator, right? These are table stakes for us. We prioritize contributions for those AWS specific integrations like cloud provider AWS and Kubernetes, right? These are the things that we absolutely have to prioritize first because we want Kubernetes to be run on AWS very well, right? We want EC2 to be the best place to run compute containerized workloads on Kubernetes. So it behooves us to focus on those integration pieces like the VPC CNI and load balancer controller, et cetera. So that is really where our bread and butter is.
Nice. And so you also, in addition to contributing upstream, AWS has also released open source software, I guess, that's come out of this work as well. I'm thinking, can you talk about Carpenter? We really haven't covered Carpenter enough in the new stack.
I can certainly cover Carpenter. I would also recommend that you do a deeper dive into Carpenter with the technical lead, Ellis Tarn, from Carpenter. In the future, I can always connect the two of you together. Right. But Carpenter, it grew out of... so I don't know how familiar you are with the upstream Kubernetes cluster autoscaler, but it is a multi-cloud provider solution that enables the Kubernetes worker nodes, the pool of Kubernetes worker nodes to be expanded or shrunk depending on, for expanding, it's depending on the number of pending pods that are ready to be scheduled, right?
Okay.
That have gone into the scheduler and there is no room on the existing pool of worker nodes for those workloads to go on. And so the cluster autoscaler needs to find a set of nodes, a node group that will be able to be expanded so that those unscheduled workloads can land on there. The upstream cluster autoscaler has drivers for GCP and Azure and AWS and Equinix and lots of providers. But the upstream cluster autoscaler uses this concept of a node group, right? And the node group is a uniform set of worker nodes that have the same instance size, right? Like the number of vCPUs and memory, etc. And so all worker nodes within a node group have the exact same size. When the implementation for the AWS provider inside Cluster Autoscaler was made, we made the choice to use the EC2 Autoscaling Groups API. And that API, the Autoscaling Group API, is sort of incongruent with the idea that a node group has to have uniform, homogeneous instance types in it, right? Because with an EC2 Autoscaling Group, you can specify a number of instance types that can have vastly different number of vCPUs and memory and disk associated with them. That has caused friction inside the AWS provider and cluster autoscaler. What Carpenter originally was designed to do was to remove that friction by having the Carpenter provider or provisioner called EC2 Fleet API instead of the Autoscaling Group API. The Fleet API is a more fine-grained approach that lets you essentially give a range of instance types and vCPUs and memory that you need, and it will just pick you an instance type that matches those criteria, but not put it into a group, right? And so this constraint of having to tightly group and couple instances together that cluster autoscaler has upstream, Carpenter got rid of that constraint. And it's able to do much finer grained placement decisions than the upstream cluster autoscaler. It also, there's a couple major differences between cluster autoscaler and Carpenter, one of which is cluster autoscaler actually embeds the Kubernetes core scheduling system inside it. And it does this in order to run experiments, right? To determine if, for instance, cluster autoscaler will say, if I create or if I scale up this particular node group with 2 more nodes, will I be able to schedule or place these pending pods on that set of nodes? Carpenter does not do that. It doesn't actually emulate scheduling. It actually goes ahead and schedules things. And so it binds a pending pod to a worker node that it has spun up using the Fleet API in the case of AWS directly. And so it sort of bypasses the scheduler in a lot of ways. It also has some abilities to consolidate, kind of like like disk defrag. Remember, like old Windows computers. You ran your disk defrag, and you see it like going and consolidating things. Carpenter has a very similar functionality to repack pods on worker nodes, because over time, sort of holes start to appear in worker nodes as pods are terminated. And so it gets a little fragmented. And so Carpenter has this ability to sort of defrag that. It also is a sort of like a full node lifecycle management system. So it can handle like upgrades of the Amazon machine images and the draining and cordoning process and things like that. So in a way, it's cluster autoscaler redefined with node termination handler and the descheduler from upstream Kubernetes kind of all rolled into one. But it does have a provider model very similar to cluster autoscaler upstream, so that it's not just AWS specific. Right now, the only provider is for EC2, but we hope to have other providers for Azure and Google, et cetera.
Now, so I'm just kind of curious. I don't know if you're in a position to answer this, but why wouldn't AWS keep that as its secret sauce for its customers? Why open source it for the competitors to use?
Well, we don't really see this as our special sauce, right? I mean, at the end of the day, it's just calling an upstream Fleet API, right, which is public and open. Anyone can call the Fleet API. Where AWS sees its value is providing managed offerings for things. So we just like EKS is a managed service for Kubernetes control planes, right? Carpenter, you still have to install it yourself, right, and run it in your cluster and operate it, right? What AWS sees as our value add is in managing and running those types of things for you. So I think it's safe to say that you will see in the future AWS offering Carpenter as sort of like a managed offering inside EKS, right?
Nice. Interesting. All right, terrific. Hey, could you also talk about CDKS? This is the AWS Cloud.
CDKs?
CDKs.
Yes.
It's the cloud development kit for,
Right. So, so CDK is this AWS specific CloudFormation synthesis sort of toolkit, right? And CDKs is very similar to CDK in its feel, right? It's you can develop using TypeScript and Go and your normal, regular favorite programming language. But instead of outputting CloudFormation templates, what CDKs does is outputs Kubernetes manifests. So you can programmatically deal with pods and services and ingress and all of these kinds of objects using TypeScript, right? And it has nice IDE integration and for syntax highlighting, auto completion, and all that kind of stuff. But at the end of the day, you can CDK synthesize those things into the YAML that Kubernetes expects. So, which is like CDK, it's the same thing, but what gets output is the CloudFormation template that then you will, execute as a stack. But for CDKs, it's the same idea, but you're working with these Kubernetes objects, and it outputs the YAML that you will then kubectl apply.
Nice. That sounds very handy.
It is. I personally am a bit of a YAML nut. I like YAML. Like there's a ton of folks out there that like hate YAML and all that, and I'm not one of them. So like I could deal with YAML all day long. But there's plenty of folks that just prefer to use their normal programming language and not have to deal with like indentation and syntax issues in YAML. So CDK is a great tool for that.
Nice. So now, obviously, Kubernetes is very important to AWS, and we cover the Cloud Native Computing Foundation quite a bit. We were checking out what was happening at KubeCon. What other CNCF projects does AWS take a close interest in the CNCF realm?
Yeah, so we have core maintainers on Containerd, FluentBit, OTel, obviously Kubernetes. We have maintainers, or at least we're trying to get maintainers for etcd, because if you think about it, producing a managed Kubernetes service at scale is basically the proper care and feeding of etcd. Right? Like we have a huge etcd footprint, right? Because each of the Kubernetes clusters that are vended by EKS, that comes along with a multi-node etcd cluster. And so, for the many thousands of Kubernetes clusters that we manage, we are managing an etcd cluster for a specific customer. And so we have a lot of operational experience running etcd, scaling etcd, snapshotting, restoring, and all that kind of stuff with etcd at scale. And so we have 2 engineers that are working to be full-time maintainers on etcd. We have full-time maintainers on Cortex, which is also a CNCF, I believe, incubating project. So we're kind of all over the place. We have maintainers in lots of these different projects. Some might say we are spread quite thinly, I guess, across a lot of these projects. But some of the, like for instance, Containerd, we have 3 active maintainers, and we're like the number 1 maintainer this last year in Containerd. We contribute quite heavily to a lot of these CNCF projects.
Nice. Now you yourself lead the AWS controllers for Kubernetes project. Could you talk a bit about that?
Sure. I do. I will point out it is not a CNCF project.
Okay.
This is so ACK is it's a set of Kubernetes custom controllers that Kubernetes users can use to interact with an AWS service. So, for instance, if I want to create an RDS database instance, I can use the RDS controller in ACK, and I can just call kubectl apply, pass in some YAML, and the controller, the RDS controller for ACK, will talk to RDS, set up the database instance, and allow you to manipulate the RDS DB instance just using Kubernetes YAML. So it's like a bridge between the Kubernetes API world and the AWS Service API world.
Nice. We've
got like 23, I think, controllers now. I think 12 or 13 are in GA. The rest are in developer preview. We're adding new services all the time. We work with individual AWS service teams in writing their controller. And most of the controller is actually code generated. Right, so it's roughly 96% of all of the Go code that comprises these individual ACK controllers is generated. We read the API model definition, and we run it through a bunch of code generation and output the actual controller implementation. So it's pretty heavy on the code generation side, but we do work with the AWS service teams because they know their API best, right? And so we work with the AWS service teams to help them build their own controller and take over maintenance of it.
So for the end user, the AWS developer or admin, this would allow them to, provision AWS services directly through Kubernetes? Or how would I describe that? Okay.
That's exactly it. Correct.
Okay.
So, if you, for instance, don't want to run Postgres in your own Kubernetes cluster and instead just want to rely on a managed RDS service, right? You can define a YAML, a manifest, right, in the ACK custom resource for an RDS DB instance. Right. Specify the engine mode, the engine type, and all that kind of stuff, and the size, and whether or not it's provisioned or serverless, and all that kind of stuff. And then just call kubectl apply, passing in that YAML definition. And behind the scenes, the controller is going to be making a bunch of calls to RDS to create the database instance, modify its attributes, and set parameter groups, and all that kind of stuff. So it just kind of allows Kubernetes users and application developers to stay in their comfy little Kubernetes world and not have to go to the AWS console, not have to use the AWS CLI or anything. They can just stay in the Kubernetes world and everything just kind of works. Or at least that's the goal. So
Nice. All the paperwork is taken care of. So now let's talk a bit more about KubeCon. So you're on the CNCF governing board, right?
I am indeed, yes. I am the AWS representative as the platinum member representative from AWS. I assumed Bob Wise's seat when Bob left AWS in February. So
Nice. All right. So I just thought we should mention that. But what was your takeaway from KubeCon? What were the communities? What were the technologies to watch? Or what struck you as interesting at this year's show?
Well, Job, I'm glad you asked that because I had forgotten to bring this up earlier when we were talking about open source contribution and everything. So the biggest topic at the strategy session for the CNCF governing board this year at KubeCon in Detroit a couple weeks ago was the upstream Kubernetes CI system and image registry costs. So right now, the Kubernetes container registry, so it's been housed at kates.gcr.io, which is the Google Container Registry. And all of the CI infrastructure that we use in the upstream Kubernetes development runs on Google, right, on GCP. We have been in a months-long effort to reduce the costs borne by Google solely for the CI system and the container registry, and spread that amongst the other contributing organizations to Kubernetes. Okay. Just to give you an idea of some of the dollar amounts here. So the container registry that stores all of the Kubernetes container images, right? The kube API server, kube proxy, core DNS, all those kinds of things. It's about 1.5 terabytes of storage data in GCR.
Okay.
On a monthly case, we were consuming $90,000 to $100,000 in egress bandwidth costs out of Google data centers and into Amazon data centers because you've got a bunch of EC2 instances that are running kubelet, the worker node agent, that are pulling container images out of Google's data centers and into AWS's. So that $100,000 a month in egress costs was eating into the total the credits that Google has provided to CNCF, about $3 million in credits. And so we've been working on a solution that mirrors the container images, the died to the blobs, the container image layers, mirrors those into S3 buckets in the 12 most popular AWS regions. Sure. And by doing that, we also set up this proxy called registry.kates.io that can tell when a caller for a particular container image is coming from an EC2 instance? And if so, redirect the image layers to the S3 mirror that's running inside that AWS region.
Yeah.
By doing that, we completely eliminate the egress costs out of Google data centers and into AWS data centers. So
you copy it once rather than,
Well, no, because there is no costs for an EC2 instance to read from an S3 bucket in its local region.
Yeah.
And so we remove a lot of that cost. Anyway, this is one area that we're working closely with the upstream SIG K8s infra in Kubernetes to reduce these costs and have AWS bear more of those costs over time. Also, Barry Cooks, who's the VP of Kubernetes at AWS, announced AWS cloud credits of up to $3 million a year and full-time engineering resources to dedicate to the core common infrastructure needs and testing infrastructure needs of Kubernetes. This was a huge deal. And it was announced on Thursday in Nate Tabor's keynote. And we discussed it later on Thursday in the strategy session with CNCF Governing Board. But I'm really hopeful that this is sort of like the catalyst, the impetus for renewed collaboration between the major cloud providers to share more of the costs for our upstream open source project infrastructure than just Google, right?
So the work would not just be for AWS, but for any cloud provider or even large enterprise if they want to do something similar, I guess.
Exactly, Joe. I mean, right now, around 70% of all these image pulls are coming from AWS because AWS has a large percentage of the Kubernetes workloads running on EC2. And so for this first sort of go around, we're aiming to cut the most amount of costs by setting up these S3 mirrors. But, we're going to do the same in the future for Azure and, just to spread the costs more around. And same with running the CI infrastructure, something called Prow. Upstream currently runs only on GCP, where we have efforts underway to bring that out of only GCP and share the burden amongst the three major cloud providers.
Is there worry that Google is handling too much of the infrastructure support?
I'm personally worried about burnout of Google engineers that currently, because everything's inside GCP, at least for the CI stuff, it is a burden on GCP engineers, and I personally worry about them burning out because they're single points of contact for some of these systems. So there isn't any danger of like Google walking away from Kubernetes or anything like that. I'm more concerned about just the personnel and the individual contributors that are sort of heroically keeping a lot of this stuff going. I would like it to not be a heroic thing, right? And that we can spread the burden across engineering resources that are borne by all of the major cloud providers.
All right, terrific. In this interview, we wanted to talk about AWS and its open source contributions to the cloud native community. And I got a good overview. I was unaware that there was so much work going on. Are there any other aspects you think might be worth mentioning to people who are interested in this topic?
Well, I think, there are a ton of AWS engineers and solutions architects and product managers that hang out on the Kubernetes community Slack and the CNCF community Slack. Come find us, right? There's lots of channels. There's provider AWS channel, Carpenter channel. There's the AWS controllers for Kubernetes channel on the Kubernetes Slack. Come find us and tell us what you'd like us to work on. Or if you have a particular issue that you found in one of these upstream projects that you think our engineers can help move the needle on, come find us. Come talk to us.
All right, fantastic. Jay, thank you so much for taking time to talk with us. And thank you, listeners and viewers, for tuning in to the New Stack Makers podcast. And we'll see you all shortly.
Thanks, Joe.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.